And for the problem, we have here a single acting compressor with a given clearance of 5% takes in an air at atmospheric pressure and a temperature of 85 degrees Fahrenheit. And it discharges its pressure at 100 psi. The air handled is, we have the given of 0.25 cubic feet per cycle measured at the discharge pressure. Now, if the compression is isentropic and air molecular mass is 29, so find the piston displacement per cycle, air horsepower compressor, and if the RPM is 750 and we have the value of your R of the air, which is 53.34, so that will be foot-pound force per pound mass degree Rankine. Okay, so in order to attack the problem or solve the problem, so initially we need to determine what are given to the problem. So that will be the initial part 2 na dapat natin gawin, no? So we have initially for the given, no? Okay. So for the given, initially the problem states that we have a clearance. So initially that will be a 5%, or it can be expressed in terms of decimals. So that will be 0.5. And next we have temperature, which is 85 degrees. So notice here in the air at the atmospheric pressure. So takes in air at atmospheric pressure. So the problem does not specify the pressure at P sub 1, but it says here we have your atmospheric pressure. So my P sub 1 will be equal to 14.7. That will be PSI absolute. So this is the absolute reading. So usually, if that is a gauge, that will be zero already, no? But if atmospheric pressure, so to make it absolute, we're going to add 40.7 psi. So it will be a zero reading in the pressure gauge. So we have your P sub 1, 14.7 psi. So I'm using psi here because the problem are more likely in the units of English unit, no? Then we have here T sub 1, or we have your temperature 1. So that will be 85 degrees Fahrenheit. So I'm going to add 460 to make it an absolute. So this will be equal to 545. So that will be degree Rankine, no? Then we have here N. So you will notice here that the compressor discharge the air of your compressor with a given pressure of 100 psi. So it will be discharging my P sub 2 is at the stage of 100 psi absolute, no? So that is also reading already. So that is plus the atmospheric pressure. Then you will notice here that the air handled is 0.21. So it means it is being handled. So this will become now our B sub 2. So that will be 0.25. So that will be a cubic feet per cycle. Okay. And this is being measured, no? So you will notice here at the discharge pressure. So that's why it is being stated that this is already in B2, B sub 2, or at the point 2, since it is being measured already at the discharge port of the compressor. Now, if the compression is isentropic air, so we have here the molecular weight, uh, molecular weight or molecular mass of air. So we have 29. Okay. So find the piston displacement per cycle, compressor, and we have the R of my air. Okay, that will be 53.34. So that will be foot-pound force. That will be pound mass, no? And that will be degree Rankine. And for my K of the air, so di naman specify yan, but automatically that will be equal to 1.4 for the K of my air. Okay. So we have firstly established now what are the given to the problem, and Also, we forgot that we have your RPM, which is 750. No? So this is rev per minute. Okay. Okay. Now I bring down here, I drawn here the PV diagram, so that we can understand the cycle process. No? So I'm going to plot here the pressure. So since we have here the pressure 1, so that will be 14 point psi. So if this is our 0, so assumingly we have here your 14.7 psi, and that will be has a correspondingly no volume for that point. No, then for my pressure 2, so this is my piece of 1. Okay, and for my pressure 2, so that will be 100. Okay, psi. So assuming it here. So assumingly, so they have the points now. So since draw here yung line, so to represent yung part na ito, since we don't have here the b sub 1, kung ilan yun, so initially I will be giving here the size, that not the size, but just only to represent yung ano ko, ang location ng p sub 1. No? It is located at this part. So we have here your point 1. No? So we have here your point 1. Okay. Then it is being compressed. No? So we have the compression going to point 2. So I will try to draw the line here representing my 100 psi. So this is 100. No? Representing that one. Okay, and this is for my uh, point 2. Assumingly, so somewhere here, so it should be steep lang naman yan siya. Okay, somewhere my point 2. Okay, then for the clearance, since we have here a 5% clearance, which is given to the problem, no? So I have drawn dito the clearance. Now for the clearance we have that one, no? Then uh, let me draw here. This is my clearance. Okay. So this represent the clearance using on the top dead center of my compressor. Now I have drawn here from 1 to 2. So this will be my compression 1 to 2. Then I have my line, no? So that will be the straight line connecting from here to here. Okay. Now this represent my point 3 at this point. And then there will be a compression again. No? So that will be a line, a curve starting here or going here for my suction. Okay. So this can be my point 4, this part. Huh? Now this represent now my call this the volume displays VD, and the other one starting from 4 to 1, so that will be my B sub 1 prime. Now B sub 1 prime represents how much is the air being intake, intake in the during the suction stroke. Okay, and I have the value of my B sub 2, this part, so that will be 0.25, that will be cubic feet. No. Okay, so let's go back to the question here. We're looking for the piston displacement per cycle. Now, for letter A, so when we say piston displacement, so that will be ang hinahanap when we say piston displacement. So how much is the volume being displaced? So we're looking for your PD. No? So yun ang hinahanap sa problem. Now, knowingly that the equation, we have your volumetric efficiency, so that is equal to my B volume flow rate B1 prime. So this is all over with my volume displaced. So referring here, we don't have the B sub 1 or yung B dot 1 or B1 prime to para makuha natin. But ang meron tayo, what we have is yung volumetric efficiency. Meron ba tayong volumetric efficiency? Let me check. So, for the volumetric efficiency, um, still, we don't have the value for the volumetric efficiency. So, kailangan nating hanapin yung value ng volumetric. Now, to solve yung volumetric efficiency, we have the equation for the volumetric efficiency. So that is equal to 1 plus the clearance minus C, and this is multiplied by the ratio of pressure 2 over my pressure 1, and this is raised to the exponent of 1 over my K. Okay. So to get the volumetric efficiency, just substitute the values here. 1 plus, that will be 0.05, and that will be, sorry, let me adjust this one, that will be 0.05 also. Then multiply the ratio of pressure 2, so we have 100 all over pressure 1, so that will be 14.7. So this is our all in terms of psi, so the units will be cancelled out, and this is raised to, just this one, raised to 1 over my 1.4. Okay. Now, pressing your calculator, so now pressing my calculator, so I have my volumetric efficiency, which is equal now to 0.8533. Okay. Or that can be said that will be equal to 85.33% for my volumetric efficiency. Now, ang kulang na lang natin, we need to find the B1 prime, no? Now, to solve the B1 prime, so that is, we can use the equation PBMRT. So we have your pressure 1, volume flow rate 1, B1 prime, which is equal to the mass flow rate. We have your R, and we have your temperature. So pressure 1 is given. Ito ang wala, and we don't have the mass flow rate, and we don't have the value of R. We have the value of R, and we have the temperature. Now, for the mass flow rate, so this is the mass flow rate 1. So we can say also that the mass flow rate at point 1 and point 2 and 3 are equal, no? And we can solve this one by using your isentropic compression to determine the mass flow rate at a given point 2. No? Para makuha natin ang mass flow rate 1, we can use also the relationship, which is P sub 2, that will be volume flow rate 2 or B dot natin doon, which is equal to the mass flow rate 2, R of the air, and we have the temperature 2. So ito meron, and this one meron din, and we have this one, and the pressure is meron din tayo. So we may able to get the mass flow rate at point 2. So knowing that yung mass flow rate 1 is equal to mass flow rate 2. Okay? So if you're going to refer, this is a fully trophic process, which is raised to pressure PB raised to K, which is equal to, which is constant, no? And we have the K, which is your 1.4. Now, what we don't have is the pressure 2. So we have the equation that is from our ideal gas processes. We have the temperature 2, temperature 1. So this is equal to the pressure 2, ratio of pressure 2 and pressure 1, which is raised to K minus 1 over your K. And to get the value of my T2, so I have my T2 which is now equal to T1, which is now equal to multiply to the ratio, which is K minus 1 over your K. Now for my T2, let's try to substitute the values here. So in, initially my T sub 1 given to the problem, which is 545, no? That will be 545 degree runtime, no? And this is multiplied to the ratio of pressure 2 and pressure 1, which have your pressure 2, which is 100 psi, and this is all over my pressure 1, which is 14.7, and this is raised to the exponent of the value of my K, which is 1.4 minus 1 divided by 1.4. So by pressing my calculator, um, the answer here for my pressure temperature 2, so it will be equal to 942, no? That will be 0.533 degree Rankine. Now to solve the value of the mass flow rate, okay, so to get the value of mass flow rate 2, which is equal to the mass flow rate 1, so continuing to run this equation, um, we have that will be pressure 2, no? So knowingly we have to get the mass flow rate at point 2, so we have your pressure 2 and we have volume flow rate 2, which is equal to the mass flow rate 2, and we have your R of the air, and we have the temperature 2. We can rewrite our equation as we have here your mass flow rate 2, which is equal now to my pressure 2, and we have your volume flow rate 2, and this is all over with my R of the air and temperature at point 2. So for the mass flow rate, we have your pressure 2, which is equal to 100 psi. So this is 100 pound force per square inch. So notice that the volume here is in terms of cubic feet, so we need to convert the inches into a square foot. Okay, so we have 1 foot, 12 inches, sorry. 12 inches is equal to your 1 foot, and I'm gonna square this one and multiply this with volume flow rate B sub 2. So noting that we have 0 point, that will be 25, so that will be cubic feet per cycle, and this is all over with the values of my R of the air, which is 53.34. So that will be foot, no, pound force all over my pound mass degree Rankine. Then multiply by the temperature T2, we have 942.533 degree Rankine. Okay, so we have now checked the compatibility of your units. So we have your square inch, so cancelled out. Cubic feet, this will be cancel yung cube, my 1 feet. And we have pound force, and this one also. So eventually cancel them, and Rankine and Rankine. Okay, we may able to get the units of pound mass per cycle. Now, pressing my calculator, so eventually ang lalabas ng mass flow rate natin dito, it will be 0.0, that will be 716. So that will be pound mass with the unit per cycle. Now that we have established, nakuha na natin yung mass flow rate, So let's try kunin yung B sub 1 prime, so using the mass flow rate. So from going back from this equation, we have your P sub 1, and it will be volume flow rate B sub 1, B1 prime. We have the mass flow rate dito, then we have to be R, and we have your T sub 1. So to get this one, so we have to substitute din directly na lang yan, no? So we have your pressure 1, which is equal to 14.7. So let's try to rewrite muna yung equation so that hindi tayo malito when we substitute the values. So we have the P sub 1, that will be P sub 1, that will be mass flow rate 1. We have your R, and we have your T sub 1. And this will be over with my pressure 1, no? So we have your B1 prime. So since yung nakuha na natin yung mass flow rate 1, so we have 0.0716. So that will be pound mass per cycle. And this is multiplied by the R of the air, which is 53.34. That will be foot pound force per pound mass degree Rankine. And this is multiplied with the temperature T sub 1. So T sub 1 natin dito, it will be for 545. So multiplying 545, that will be degree Rankine. And all over natin ito. So we have the pressure 1. So what is the pressure 1 natin dito? Going back, PV diagram, pressure 1 is 14.7 psi. So that will be 14.7. So this is pound force per square inch. So let's convert this one to foot. We have 1 foot. Okay. And this is squared. So eventually, cancel yan. And my pound force will be also cancelled. Degree Rankine, and my pound mass will be cancelled also. So matitira na lang sa atin dito will be in terms of cubic feet. No? So square inch, this is squared already. So we have the value of B sub 1 prime. Now, pressing your calculator, you may able to get the value of B sub 1 prime. So that is equal to 0.983. No? This is the unit of cubic feet per cycle. So, meron na tayong B sub 1 prime, and we have already the volumetric efficiency. We may able now to use this equation to get the volume displaced. Okay, so for the volume displaced, so we can rewrite our equation from there. That will be B1 prime, that will be divided by volumetric efficiency, and where my volume displays, so that will be value of B1 prime. So ito yan is 0.983. So that will be cubic feet, no, per cycle. And this is over natin ng value ng volumetric efficiency mo, which is 0.8533. So pressing your calculator, so for the value of volume displays, so we have 1 point, no? 1.152. So that will be cubic feet per cycle. Now next, letter B. Okay. For letter B naman, so for letter B, we're looking for the horsepower. Okay. So knowingly that the equation for your work, we have that will be K P sub 1, and that will be 1 prime. So this is all over with my 1 minus my K, and this is multiplied by the ratio of my pressure 2, pressure 1, and this is raised to k minus 1 over your k, and this is minus 1. So you will notice here B1 natin, so that is 0.983. So in terms of cubic feet per cycle, no? So now to get my B1 or my B1 dot, uh, so to make it in terms of we call this in terms of RPM, no? So to get the value of my B1, okay. So I'm gonna erase this one. Okay, so B1, now B1 prime. To get the value of my B1 prime, so that will be my B1 dot prime. That will be multiply natin sa RPM. So that is B1 prime is 0.983. So this is cubic feet per cycle. And we have yung N, which is 750. So that will be revolution per minute. Okay? Or it can be said that it can be also state that it is also in terms of uh, cycle, no? Since this one revolution is also one cycle, no? So it can be said na ganun siya, no? It will be cancelled out, and we may able to find the value of b sub 1, no? So by multiplying it by the RPM, so we may able to get the 737.25. So that will be cubic feet, no, per minute. Okay, so since if you will try to examine the equation, so yung work na compressor, so yung K natin given, P sub 1 is given, and we have yung B1. So lahat yung may values na, we can directly substitute the values in the equation of the work. So we have the yung K, which will be 1.4 times my pressure 1, so that will be 14.7. This is pound force per square inch. And I'm gonna change this one to terms of foot, and it will be 1 foot square this one. And ano pa ba yun? We have the volume 1. So yun, nakuha natin yun. So that will be 737.25. That will be cubic feet per minute. No? So let's try to convert this one also in later on lang, no? We keep the minutes, the units per minute. Then this is all over, no? All over divided by 1 minus 1.4 for my air, and this is multiplied with the ratio of pressure. So for the pressure, so we have pressure 2. Now for the pressure, we have 100 psi. This is all over with my initial pressure 14.7 psi absolute. So square this one, raised to 1 to the power of k minus 1. So that will be 1.4 minus 1 all over 1.4, and this is minus 1. Close parenthesis natin yan. So for the work, now we may able to, so let's try to cancel the units here. Kung anong maiiwan ng units, so the squared, cubic feet squared. So this is minute. So we have foot pound force per minute, and this is PSI will be cancelled out. So by pressing my calculator, I'm able to get the value of 39. So that will be negative 3984. Okay. 3984, that will be 385, 0.18, no? So this is foot pound force per minute. Okay, And we have the conversion that 1 horsepower, this is equal to the value of 33,000, sorry. So this is 33,000 we put pound force per minute to convert it into horsepower. So we have your work in terms of horsepower, that will be negative 120. So this is negative 120.739 horsepower, or let's say it equal to negative 121 horsepower, no? If we try to round up ng value. Next, for the question letter C, what is the power required to run the compressor when the mechanical efficiency is equal to 85%? Now, the mechanical efficiency, which is equal to 85%, no? So we have the equation knowingly that my mechanical efficiency is equal to the work indicated divided by the work break. Hmm. Now we're looking now for the value of your work break. So I can say that my work indicated now is divided by my mechanical efficiency. Okay. So where my work indicated is equal to 120.739 horsepower. So I will be using the decimal places na lang muna, no? Just to to keep the decimal places from the previous solution. So to solve that one, we have your work break. Work indicated, that will be negative 120. Now I'm going to remove the negative sign here, since only uh, the negative sign here indicates the it only indicates that it is the na yung work is being supplied to the system, no? So that will be a negative, rather than the system. If the system is producing work, so that will be positive. So yung negative sign yan, so that indicates only the direction of the work. So if the work is being supplied, it will be a negative. If the work is being produced by the system, it will be a positive. So gamitin ko ng positive dito, so I will be using 120.739 horsepower, no? And it will be divided by the value of my work break. So sorry, ng mechanical efficiency, that will be 0.85. So this is equal now to 142, no, 0.04 HP. Now next questions we have here, for letter D, what will be the polytropic work in terms of horsepower when the polytropic compression efficiency is given by 75%? We have the equation that the polytropic efficiency, no, and polytropic is equal to the work polytropic, all over divided by the work indicated, or that can be a work isentropic, no? Since yung ano natin dito sa problem initially, sa letter D, given na yung ano natin, fully tropic compression efficiency, which is equal to 85%, no? Okay. So we have already our value ng work isentropic, which is 120.739 horsepower, 0.739 horsepower. We may able to compute the work polytropic. Now rewriting my equation here to get my work polytropic. So work poly, so that will be equal to the N polytropic, then this will be multiplied by the work isentropic. So substituting the values here, we have your n of polytropic, so that will be, sorry, this is not 75. So let me try to erase this one, rewrite this one. This is 75%, sorry, 75% coming from there. So we have 0.75 work percent, then multiply by isentropic. So that will be negative 120.739 horsepower. Okay. Now by pressing my calculator, so this is equal my work polytropic poly is equal to negative, that will be negative 90.5542 in terms of horsepower. Now next question, for my letter E. So what will be the polytropic overall efficiency? Now for the uh, overall polytropic efficiency, we have the equation that will be NOP. So the that symbolizes the overall polytropic efficiency, which is equal now to your mechanical efficiency, no, times my polytropic efficiency NP. Okay, which is yung kanina nakuha natin, that will be NP, no? And this is equal now, if you're going to break down yung value nito ng mechanical efficiency, we have your work indicated, and this is all over my work break. Okay, and multiply ng work polytrophic o work poly na lang para maikse. So that will be all over divided by yung value ng work polytropic, which is uh, work indicated or work isentropic, no? So this is work indicated, or that can be work isentropic, no? Close parenthesis. Now you will notice here pareho ito sila, no? So I can cancel this one and I can cancel this one. So to get my polytropic overall polytropic efficiency, that will be work poly, and this is all over divided by ng value natin ng work break. Now to substitute yung value from the previous, we have the work polytropic, so that will be negative 90.5542 horsepower, and it is all over divided by ng work break natin. Nakuha na natin ito, ang work break natin, it will be, so from here we have 142 yung work break. So again, yung kanina sabi ko nga, it will be also a negative sign din yan, just on notingly that the sign negative indicates the direction. So I can put here, so para mag-cancel yan, I can put here also a negative sign. So we have here 142, no, 0.04 horsepower. Now by pressing my calculator, now my overall polytropic efficiency now is equal to, so that will be 63.75, so 63.75 percent. Next, for letter F, the question will be how much is the heat being rejected by the system, no? So how much is the heat rejected by the compression now in the units of we have here units of BTU per minute. Okay, so knowingly that my heat rejected, we have UQ rejected, So that will be equal to my mass flow rate, and that would be specific heat of air at constant pressure, then multiply this one by T2 and your T1, no? And sa problem does not specify the value of your CP. So may mass flow rate 1 tayo. So this is all equal for every state naman, di ba? Ang wala na lang tayo is the CP. So, sa problem, hindi na-specify what is the value of the specific heat of the air at a constant pressure. But we may able to solve this one, no, by means of CP. So knowingly the relationship that the CP is equal to K times my R, and this is all over, that will be K minus 1, no? Ang K natin, it will be a 1.4, no? And this is being multiplied by the R of the air, which is given to the problem already. That will be 53.34. So this is put pound force and pound mass. It will be degree Rankine. And this is all over with 1.4 minus 1. Okay. So, pressing your calculator, the value of my CP, that will be 186.69, and that will be foot pound force, pound mass, degree Rankine. Next, pwede natin substitute, but mapapansin nyo, you will notice here our mass flow rate is in terms of unit of pound mass per cycle. Okay, so what we're going to do is the same yung ginawa natin previously. We multiply it by the RPM, no? For my mass flow rate, so para magkaroon tayo ng in terms of minute, pound mass per minute, in terms of flow rate, no? So that will be equal to mass flow rate 1, no? Then this is multiplied by the given RPM. Now for our mass flow rate, so that will be 0.0716. So that will be pound mass per cycle. Okay. And we multiply this one by the given RPM, which is 750. So this will be multiplied by 750 rev per minute. Okay. So I may able to get my mass flow rate now is equal to that will be 53.7. That will be pound mass per minute. Now, to solve the heat rejected, so we are completely good to go now. Meron na tayong lahat ng mga value niyan. We able to solve the value Q rejected. So, for my Q rejected, so that will be 53.7. That will be pound mass per minute. Then multiply by the given calculated specific heat, which is 186.69. So that will be put pound force, uh, pound mass, we have degree Rankine, and this is multiplied by the change in temperature from point 2 to point 1, no? Where my point 2, which is given din sa prob na kumpitan natin yung temperature at point 2, that is 942.533. So 942.533, that will be degree Rankine, minus my initial temperature, which is 545. This is 545 degree Rankine. Okay. Now, by pressing my calculator here, so my Q rejected now is uh, equal to, that will be, so mahaba ito, no? So it is equal to 398, that will be 5569.406. Now the unit is foot pound force per minute, and we have the conversion that that will be 1 BTU is all over equal to 778. That will be 0.169. So this is per pound force. No? So after converting that one, so my Q rejected in terms of are now in BTU per minute, which is equal to 5,121.727. So that is BTU per minute. Now for the next question for letter G. So what is the length of stroke and the cylinder bore when the bore to stroke ratio is given as 1 is to 1.5? So express the answer in foot. No? Um, so what are given here, we have already nakuha na natin yung volume displays. But noting that my volume displays, that is equals in terms of cubic feet per cycle. So we need to convert this one first in terms of per minute, no, cubic feet per minute. Okay. In order to do that, our volume displays will be multiplied again by the RPM. No. So let's subtract to that one. So that will be volume displays. That will be your BD. That will be multiplied by the RPM. So I have my BD, which is 1.152. So this is cubic feet per cycle. Then multiply it by the given RPM. So balikan natin yun. What is the RPM? So that is 750. Okay, so this is 750. That will be rev per minute. Okay, so this is cancel. Now we have the value of your volume displays, that is equal to 864. That will be cubic foot per minute. And knowing that my volume displays equation is also equal to, that will be the bore. Okay, so that will be the diameter of the cylinder. So pi over 4, then diameter of the cylinder squared, then this will be multiplied by the length of stroke and the given RPM. No? So, ang hinahanap natin dito, we're looking for yung stroke. So, that will be yung L, and bore. So, what will be the diameter? No? We can express the ratio, which is, ang sabi doon sa problem, we have the bore to stroke ratio, no? So if you're going to express that one in equation, yung bore, that will be D over L. So that will be bore, and we have stroke. So kaya tinatawag ng bore to stroke ratio. and this is equal to the value of 1 over my 1.5. Okay, now in order to get yung bore, so I can or I can to get the stroke, so I can uh, rewrite the equation here. So my D is equal now to L over my 1.5, no, to express. Then I can substitute this one to the equation, since given na yung volume displaced natin. So I can rewrite the equation here that BD is equal now to pi over 4. That will be the value ng D, that will be uh, L over 1.5, no? So I'm gonna square this one, and this will be squaring this one and multiply by the L, and I have the and my N, no? Tapos, distributing that one sa equation, I can say that my pi over 4 equation nito, it will be yung L ko, uh, pasok mo doon, that will be expressed as my L cube, no? Over my 1.5. So this is squared, and I have my RPM. Now, since ang volume displaced natin is 864, so I can write here 864. So that will be cubic feet per minute, di ba? And this is equal to 5 over 4. That will be uh, bore to cube. Then I have 1.5 squared dito sa ilalim. Then, yung N ko, that will be 750. So that will be revolution per minute. Okay? So usually minutes will be cancelled out doon sa both sides. Then, finally, using my calculator, I have the value of my length of stroke. And this is equal to 1.484, no? So that will be foot. Okay. So this is now my length of stroke. Now, for the bore naman, okay, so coming from this equation, no? So from this equation, I can say that my bore, that will be is equal to the length, that is 1.484, that will be feet, and this is divided by 1.5. Okay. Now, I have the ratio of the bore of 0.99, no? Foot. Okay. Or we can say that will be 1 foot for the bore. Okay. Now, next question is for letter H. So, how much energy savings in horsepower when two-stage compressor is used to replace the single-stage compressor? Okay, so I bring down here the PV diagram and the schematic diagram ng two-stage low low stage cylinder and a high stage cylinder of a compressor when making a multi-stage compressor. Now we're going to rectify the PD diagram in order to adapt the schematic diagram ng two-stage compressor. Now first things first, we need to determine what will be the intermediate pressure between 100 and 100 psi to between 14.7 psi. That will be the piece of X. So we have the equation from the to get the intermediate pressure. We have the uh, call this the piece of X. So that will be the piece of X. So that will be the square root ng dalawa na ito. So that will be multiplied by piece of 1 times the piece of 4. Okay. Now we have the square root of this one. So that will be piece of 1. That will be 14.7. That will be psi absolute multiplied by 100 psi absolute also. Okay. Now we may able to get the value of the P sub x. So that will be 38 point 341 psi absolute. Okay, so P sub x now represents the pressure in between the P sub 2 and P sub 1. Now, to represent this one, so assumingly, nandito siya, no? P sub x na yan, which is 38. So, mabababa siya. Okay. So, I can draw here yung in between na yan. So, assumingly, no? Okay. And this represent my P sub x, which is 38.341. So, let me rewrite this one as parang kung masyado siya sa figure, we have 38.341. Okay, so that represents my intermediate pressure in between the low stage compressor and the high stage compressor cylinder. Now, gonna write here, this will become my point 2, no? Ito na yung point 2 natin. Then, referring to this figure, now, if we will try to interpret yun, ito yung point 1 natin, and this is my point 2 uh, part, no? So, ito na yung 1 and 2, and then, ang mangyayari is that after the point 2, so, there will be an intercooler. So, eventually, if you compress the gas, it will eventually from the base of the PBMRT and the gas laws, eventually it will raise the temperature if you compress the gas. But we have an intercooler to cool the gas, no? So in order to have a minimum work, no, for the high stage compressor. Now this is now our after the compression 1 to 2, the gas is being released along 2 to B. Okay? So if we will try to draw that one, 2 to B. So ito yung part na yan. Since pababalik na rin yan, it will be 2 to B. Okay? So compression, then process that is being discharged 2 to B. So we have here 1 and 2. So that is being discharged to high pressure cylinder. Now, we have yung intercooler. So itong intercooler cools the temperature of the discharge gas. Usually, if you're going to compress the high pressure cylinder, low pressure cylinder, it will gain a heat, yung gas dito, and it is passed through the intercooler. So papalamigin siya with the circulated water. Now, nangyayari dito, the intercooler, it is being believed that uh, the temperature now at point 3, so we have here your point 3, um, at point 3, no? So this is my point 3 na natin dito. So that will be the point 3. It is being believed that the temperature T3 is equal to your T1. So that is the purpose ng intercooler is to lower the temperature in such a way na it will be equal to temperature 1. But the pressure is still the same. We have here intermediate pressure. So yan tinatawag na MCP delta T. So that will be the heat being rejected to the atmosphere or outside of the system. So at a constant pressure. So we're using here constant pressure or yung tinatawag na specific heat at a constant pressure. So that is being released to the environment or being released or being absorbed by the cooling water. Now, going to the high stage, so we have the process 3 to 4. So usually we have the process natin dito 3 to 4. So that will be the compression natin dito. So from high pressure cylinder. Now the gas, no? The gas of our suction here. So usually the suction start ng 3. So that will be starting at point E. So nandito yung part na yan, that will be the point E. So the suction of the gas of high stage compressor, So starting from this part, so from E, no, going to 3, no? So we have here 3. So from 3, it will be in compressed 3 to 4. So we have here the compression 3 to 4. So let me try to draw here yung 3 to 4. Yan, yung process 3 to 4. So this will become a compression 3 to 4, and then the gas is being released to 4 to F. Okay, and if you're going to draw the line here, we have the discharge port here going back doon sa letter E. So the cycle continues from E3, 4F, and we have the cycle. This is for high stage, and we have for low stage that will be 1, 2, E, and so on going through the cycle. Now, let's try to compute na yung work ng kabuuan, no? The system of the two compressors. We have the equation for the work of the compressor. So we have your work of the compressor. So that will be equal to 2 times my K, and we have the mass flow rate that will be multiplied by R and temperature 1. And this is all over with that will be we have 1 minus my K, and that's be multiplied by the change in pressure, no? My So that will be the P sub X, intermediate pressure ratio with a P sub 1, okay? And this is raised to K minus 1 over my K, and this is minus 1. Or we can express this equation as 2K mass flow rate R temperature 3, no? Divided by 1 minus K, and the ratio of pressure of P4 and P3. So where my P3 is also equal to my intermediate pressure, and that will be raised to K minus 1 over K minus 1. Okay? So it's either saan dito, so I have right here that the pressure 2, pressure 3 is equal now to my P sub X, no? So let's try to solve the problem or substitute yung values doon sa work natin dito. We have your work. So I have equal this 2, no, times my 1.4. Then the mass flow rate. So balikan natin yung previous problem here. What we're getting is the mass flow rate that will be yun, that will be 53.7 pound mass per minute. So that will be multiplied by 53.7. So this is pound mass per minute, and multiply by the R of the air. So that is equal to 53, no? So we have the value that is 53 point 34. So that will be foot pound force foot pound force. Sorry, this is pound mass, and that will be degree Rankine. And the initial temperature, we have checking that one. So we have the initial temperature is 445, no? So this is 445. Sorry. So that is 545 degrees Rankine. Okay. So and this is all over 1 minus my 1.4. Okay. Then will be multiplied to the pressure ratio, which is 38.41. So that will be PSI absolute. all over with my initial pressure, which is 14.7 psi absolute. And this is close parenthesis raised to the exponent, which is your k. That will be 1.4 minus 1 all over my 1.4, and this is minus 1. Let me try to change this one since this is, so let me try to erase this one since nagkamali, forgot to put this, change this one to value. So just an error here. So that will be 341 psi absolute. Okay. Now if you're going to press that one sa calculator, so that will be equal to that will be 3. So that will be 3,443,172.41 foot-pound force per minute. Now, if we will try to convert this one in terms of on horsepower, so we may able to get a value of negative. So this is already a negative value. No? So it will be 104. No, 104 point. That will be 34 in terms of horsepower. Now to compute the energy saving, let's go back from the previous. We have uh, the work indicated, no? Uh, so we have the work indicated that is 120, okay, 0.7349. So I have 120 from the previous work indicated, then minus the new work by means of making a multi-stage. So we can say that we have a 16 horsepower. No? Sorry, that will be 16.4. So it is a 16.4 horsepower for the energy saving. Now for the next questions, we have how much is the heat needed to remove in the intercooler? So we have your intercooler to cool the gas to its original temperature. So express the answers in BTU. Now the equation about the heat rejected in the intercooler. So that will be intercooler heat rejected. So that is equal to the mass flow rate of your air, then the specific heat of the air times the change in temperature from T3 to T1. Okay. So for the mass flow rate of the air, so that is given, that is already given, that is 53.7. T3, sorry, this is T2. Okay. T3 minus your T2, so we have the change in temperature from T3 to T2. T3 to T3 to from 3 to 2. Okay. So specific heat, no? So for the specific heat of my water, so that is equal to 1 BTU, no? That will be pound mass degree Rankine. Okay. Then for the temperature T3, so yun ang wala tayo. T2, do we have the temperature T2? So hindi rin binigay sa problem, but yung T3, ang T3 natin, it will be equal to your T1, which is equal to 545 degree Rankine. So returning the temperature of the gas to its original point, which is initially given as a problem, the temperature at T1. Now, what we don't have is the temperature at point, point 2, no? Sorry, we're talking about pala dito. That will be, so let me change this one. So, this is supposed to be the specific heat of so that is the specific heat of water. So air that is already computed previously, that is 186.69 foot-pound force per pound mass degree Rankine. So remembering, we have here the process from 1 to 2, so that is an isentropic compression. So remembering from the isentropic process of our ideal gas, we have, so assuming it is an ideal gas, so we have your temperature T2 and T1 that is equal to the intermediate pressure P sub X and P sub 1. So that is raised to K minus 1 over my K. Since we're looking for your T2, so we can rewrite our equation to T2 is equal to your T1. That will be multiplied to the ratio of P sub X and your P sub 1 raised to K minus 1 over your K. Now, let's try to substitute yung value dito. So, your T1, we have, that will be 545, no? Degree runtime. Then, multiply by the intermediate pressure. So, that will be 38.41. So, this is PSI absolute all over my P sub 1. So, that will be 14.7 PSI absolute. And raised to 1.4 minus 1 all over my 1.4. Okay, so this is now equal to your T2, which is equal to 716, no? 0.72. So this will be degree runtime. So complete na yung mga requirements natin to, in order to solve the intercooler. So let's try to substitute that one to the equation. We have your intercooler. So that will be mass flow rate is 53, no? That will be 53.7. That will be pound mass per minute. And multiply by the specific heat, that will be 186.69. So this is foot pound force, pound mass. Then degree runtime. Now the change in temperature, we have the T3, that is 545 degree runtime minus my temperature, which is 716.72 degree runtime. Okay, so by pressing your calculator, I have a value of negative 1,721,586.57. So this is called this. The units is the unit will be, so usually this will be cancelled. What we have is foot pound force per minute for the unit. Then we have the conversion of one BTU is 778.169 foot-pound force. So we may able to get the value of negative that will be negative 2,212. Let me pointer to 6. So this is BTU per minute. Now for the last question here, letter J, that will be if the multi-stage compressor is cooled by an intercooler and it is water-cooled design, if the change in temperature jacket water to cool the intercooler is 25 degrees Fahrenheit, calculate the mass flow rate in pounds per minute on the jacket water. No, the specific heat of water given as 1 BTU pound mass degree runtime. So again, we have here uh, water entering and water leaving. Now, the change in temperature or the rise in temperature of the jacket water is 25 degrees Fahrenheit. Now, we need to compute how much is the water provided to circulate in the intercooler to cool the intercooler. Now, I have bring down here, I isolated the intercooler. So, by means of isolating that one. So, I have at this point, so this is my point 2. On the other end, that will be my point 3. And the flow of the system is like this. So, papunta doon. And we have water entering and water leaving the intercooler. Now, if we will do an energy balance here, so energy entering from our steady flow energy equation, energy out now. Uh, we can say that our entering energy, we can write here that we have mass flow rate of your air entering. So this is M2. And we have also the mass of flow rate of air leaving the system. And I have also a mass flow rate of jacket water leaving the system, entering, and mass flow rate of the water that is leaving the intercooler. This is entering, and this is leaving. Okay? And yung point 2, we have the corresponding temperature dyan. So let me write this one, that temperature T2. So that is from the previous, we have calculated that is 716, no? Let me try to rewrite this one. So this is T2 is 716 0.725, that will be degree Rankine. And for my T3, so usually this will be going back to its original temperature. So we have 545, no, degree Rankine. And the problem says that previously we have the rise in temperature ng water, or that will be the change in temperature. So that is equal to 25 degrees Fahrenheit. Now, we will apply here the steady flow energy equation. Energy in, you have your energy out. Okay, so for energy in, we have the mass flow rate of water. So yung ano natin dito, this is equal to the mass flow rate of air, no? So gawin na lang natin siya ng M. So this is also equal to the mass flow rate. So mass flow rate of air entering is also mass flow rate leaving the system, no? So we have entering, so that will be mass flow rate. No, that will be the mass flow rate, which is your M2O. That will be multiplied by the specific heat of air, then multiply by the temperature T2, okay? And plus, which is also entering, we have the mass flow rate of the water, then the specific heat of your water times the temperature of water, no, entering. So we have temperature of the water for my in, no, so that is entering. Then it is equal. Now for the energy leaving the system, we have the mass flow rate of my air, then specific heat of my air. So this one is leaving, no, palabas the system. Then multiply by the temperature T T3, no? Then plus, which is leaving also, we have the mass flow rate of my water, and then this is multiplied by the specific heat of my water, constant pressure, then times the temperature of water. that will be leaving, T out. Now let's combine yung both terms. So we can combine here the air and water. So for the change in temperature for each properties. Now I can rewrite here that the mass flow rate of my air, that will be multiplied by the CP, specific heat of air. So that will be temperature T2. So if you're going to transfer this one, so they are same, you can factor that one. So it is equal now to T3. So magiging ganyan yung equation. So if you're going to transfer that one, factoring the common, so we may be able to achieve the MCP delta CP of air T2 minus T3. And on the other side, so that will be the mass flow rate of my water, then specific heat of your water, then will be temperature of my water out minus my temperature of my water in. So again, we try to factor pa rin yan. So if you're going to factor, which is yung M mass of water and specific heat of your water is the factorable. So we can just only, if you're going to distribute, so ganun pa rin yung magiging mangyari dyan, no? Yeah, this is a review from your algebra. So we have this equation now. So since ang hinahanap natin sa problem, we want to know what is the call this the mass flow rate of water. So we can just simply transpose this equation to the other side. Okay. So let's try to do that one. So that will be mass flow rate. So that the mass flow rate. Okay. So transpose natin dito on the specific heat. So we have the CP of your water. So that will be times, no? So I'm gonna change this one to the rise temperature rise, no? Since yung ito is can be equated as the change in temperature or the temperature rise. So that will be changed to temperature rise, or we have here this one, no? So I can say na ito is equal to the change in temperature T rise. Okay? Ayan. Just only two. Then this is equal now to the mass flow rate of my water. And we can also write now dito that itong equation na ito, we have this part, yung MCV air. So this is the Q ng intercooler. So we can equate that one. So pwede natin i-equate yan, that's the intercooler. And this will become now my equation as my Cp of my water times the change in temperature rise. Okay, so we can now substitute the heat that is being rejected from your intercooler. Now this is equal now, no? So I'm gonna put here the value for the heat. So that will be 2000, no? That will be 212.36. So this is BTU per minute. Okay, and the specific heat of water previously, which is given to the problem, that will be 1 BTU pound mass degree Rankine. So I have 1 BTU pound mass degree Rankine. Then the rise in temperature, we have the rise in temperature, so that is 25 degrees Fahrenheit. Now this is already change in temperature. Now if we're going to initially, if we're going to plus or minus yung we're going to plus a 460 degrees Rankine, so eventually it will be cancelled out, no? So, ito magka-cancel na. Eventually, this is can be expressed as a degree Fahrenheit or a degree Rankine. So, for the purpose na to represent, no? So, we can say that this is a degree Rankine also since this is already a rise in temperature. So, if you're going to plus the value for initial state to the final state, so that eventually will lead you to cancellation of the absolute at the yung ina-add natin na 460 degrees in order to make it absolute, no? So, eventually will be cancelled out. Now, so doing that, so we may able now to solve the mass flow rate of the water, which is equal to that is equal to 88, no? So I have 88.49, or it can be said that is 88.5. So we have the unit of pound mass per minute. So that will be the mass flow rate of the water in order to sustain the temperature or the change in temperature inside the intercooler. Now, this completes the solution for the problem, solving the problem letter J. No? So, and this also completes the solution for the questions of the given problem. So, I hope na naintindihan ninyo. So, if for any questions, you can message me or directly talk to me for any clarification for the solutions.